Welcome to GateX AIML. In this video, we will discuss about row echelon forms and column echelon forms. Then from that, we will see the row space, column space, and the null space. We'll try to understand. These help us in reducing the system of linear equations to solve many mathematical problems. Okay. So before understanding this, let us have a basic understanding of vectors. I am not going in depth in vectors in this video. A separate subject made for it. Let's understand vectors in terms of the concept of matrices. Okay. So what is a vector? Vector can be seen as a matrix with either a single row or a single column. So if I take a matrix, say n cross n matrix. So how you write n cross n matrix? We write as that belongs to real number n cross n. Okay, this is how you write it. Now, if I take one column in that matrix, that becomes my column vector. Okay, we call it as vector, and it is n cross 1, that is n rows and 1 column is column vector. Similarly, a row vector is 1 cross n matrix, that is 1 row in your matrix form a row vector. So for example, this is a given matrix. So this is 3 cross 4 matrix. So for example, a column vector, I take this one column, let us say this is my vector v. So this is a column vector. Similarly, if I take this row, okay, this becomes my row vector u. Okay, so that's the concept, basic understanding of what is a vector from matrices. Now we'll jump into the echelon forms and spaces. What are these? What are going to learn in this video? See, you are just trying to find all these rows and columns, which are all linear combinations of given vectors. Means we are going to reduce these matrices, given matrices. The matrices actually forms the or gives the solution for our any equations, okay, set of linear equations. In the next subsequent videos, I will explain what are these linear equations and how to get the solution form for them using matrices. Thus, we are building the basis for all those things. Okay, so we'll be studying here. Okay, what is this echelon forms, and then how it will help us to get the row space, column space, and null space. Okay, so some keywords or why we need echelon forms, because they help us to give the independent rows in my matrix or independent columns in my matrix. Okay, and which variables are free variables. The free variables means using those I can directly find the solution to my linear equations, and it also helps us to find the rank and dimensions of the matrix. So we'll see it next. Now we will be using some terms here like span and all. This span is nothing but set of all linear combination of given vectors. In the previous example, so if I take this four column vectors, okay, these 4 column vectors, okay, I can write like this 4 vectors, column vectors. So this entirely we call it as this set. This we call it as span. Okay, span. So that is the meaning. Similarly for your row vectors. Okay. Now what is row span? We will understand in depth next, but just have some imagination what it means. Span of independent rows of matrix. See, from the given matrix, I will what is that basically we're going to do here? We apply the echelon forms. Okay, convert the matrix into echelon form. We learn how to convert it, and then from that we'll find out which are all the rows or columns which are independent. So all the rows which are independent will form the row span or row space. The span of those independent rows forms the row space, and then the span of independent columns forms the column space. And the null space is how to solve these solutions, how to get the solutions for these equations. That we will see. Okay. So now, what is row echelon form? Okay, we shortcut in short way is the REF, row echelon form. So what is the condition for a matrix to be in row echelon form? Why you are using this row echelon form? I told you to form the independent rows. Okay, so that is basically you are saying reduction of your matrix. All non-zero rows are above any rows of all zeros. You have to convert a given matrix. The first condition is all non-zero rows are above any rows of all zeros. So this is, for example, is the row, the third row is all zeros. This should be the last. So any non-zero row, non-zero, this is a non-zero row, this is a non-zero row, should be above the zero row. Okay. Then there is a concept of pivot element. The first non-zero entry of each non-zero row called a pivot. Okay, so let us say this row, first row R1, first non-zero entry, okay, of a non-zero row. This is a non-zero row 1, 2, 3. So this is my pivot element. And so it should be, if there is another pivot element, for example, say that this row 2, so 0, this is a non-zero row 0, 1, 4. Okay, so the pivot element is the first non-zero item. So this is 0, I cannot consider this one. This is a pivot element, can also be a pivot. So what is the condition here? This row 1 is above row 2. So this pivot element should be here. So to the right of the R2. So R2 is to the right of R1. So that is the condition. So if there is one here, there should be pivot element here. This is how you have to convert into a given matrix into row echelon forms. So entries below each pivot are 0. So here entry below 1 is 0. Entry below 1, this pivot is 0. So this is 3 conditions you have to follow to make a given matrix into row echelon forms. So if you get something like this, see this row I am making independent, right? This is independent. This can give me a free variable. We will see in null space what is this free variable means. Okay, these concepts you learn. Okay, everywhere you learned it, everyone teach it, but really what it means, I'm giving the specific definition. You should understand this because when you solve complex problems, so you should understand the terminologies. Although you know how to solve, how to get rank of a matrix, how to get the echelon form of a matrix, it is not sufficient because if you follow a procedure to get that, but you should understand what is a procedure, okay, so that you can answer many questions. No. So let us take an example, you'll understand in a better way. The only thing is you know how to solve this. Okay, any books you go, any other lectures you go, they will tell the procedure. I am just giving the same procedure but with technical meaning to it, so that tomorrow when you go for any interviews or anywhere, when you solve many problems, the question is very technical. I mean, like they are not mentioning anything like row echelon form or something like that. You should be able to position using the terminologies used there to apply this. Okay, that's why I'm giving this procedure. Anywhere you see remains the same. The only thing I'm attaching the technical words to it. Pivot elements, row space, column space. When you again learn the vectors in depth, it will be very helpful. Now, to take this example to matrix 1, 2, 3, 2, 4, 6 and 1, 1, 1. The first thing is what? To convert it to row echelon form. Okay, there are two types, row echelon and column echelon form. So first you are seeing converting into row echelon form. Okay. So what is my goal? So I have to have 3 steps to follow. 1, make non-zero rows. Try to find non-zero rows and 0 rows. Okay, rows with 0 elements. Not 0 elements, all the rows having 0 as the value. Okay, and then bring those rows to the bottom. So for that, first you find the pivot element. Pivot element is, let us take this R1. This is the pivot element here. Pivot element is the first non-zero element. This is my pivot element. You select it. Okay, next. Now, the second thing is, okay, what is the point there? Every row, every element below the pivot element, the third point in row echelon form, every element below the pivot element, I chosen this as the pivot element, should be made 0. How will you make it 0? So how will you make it 0? To make this 0, what is that I have to do? I have to subtract -2 from this. So how will I get it from this? So this is called as row reduction. So let us say this is R2, so what I want to change. So changing the orders will not change the equation values. You will get the same solution. So that is the concept of the matrix. That's row reduction. So you can multiply it. Okay. So how will you write R2? R2, to make this 0, I will write R2 minus 2R1. Okay, so entire row multiply by 2 and subtract it from R2. So it will become what? This will become, this will remain same R1. R2 will become 2 minus 1 into R1. Okay, so 2 into R1, that is 2. So this, we observe here, this will become 0. This will remain same. Okay. Now, and then similarly to perform C. So now I have to bring this, right? I have to bring this 0 row below. Because there is a pivot element here, minus 1. I have to bring it up. So to do that, you can up. See, it's left to you how you bring it. Okay, you can change the sign and bring it. Okay, you can do anything. So now this was my resultant matrix now. So I have to bring this 0 here. So I will say swap it. I will say R2, row 2 and row 3 I will swap. So what it will become? This will be 1, 2, 3, 1, 1, 1, then 0, 0, 0. Okay. Now, next what? See, this is the pivot element, right? Again, so any element below this should be 0. This element I have to make it 0. How will I make it 0? So I subtract again. So R2 is equal to R2 minus R1, row 1. Okay, row 2 minus row 1. So what I will get? I will get, this will remain same, 1, 2, 3. Then subtract this means 0, minus 1, and then minus 2. This is 0, 0, 0. Okay, that is the next step. So that's what we're done here. Next. Now, if you observe here, this is done in different way. Okay, we'll solve it completely here. So now, what it says, there is one more rule, right? So this is pivot element and here should be a pivot element, but it is minus 1. So if I make it plus 1, it will be same. So just make R2 as minus R2. Okay. So change the sign of it because you are changing the entire row sign, so it will not affect. So 1, 2, 3, 0, 1, 2, 0, 0, 0. Okay. So you check now row echelon form conditions. First element is pivot element. Okay. Right to it. Second pivot element right to it is the second pivot element. Okay. This all follows. Element below this is 0. Element below this pivot element is 0. Okay. Can you further reduce it? No, cannot further reduce it. So this is the row echelon form of the given matrix. Okay. So this is how you have to find the row echelon form. What is that we have got finally? So you can change in any order. So in the example of how I solved and how it is given here is different, but you will arrive at the same result. Only thing is how you interchange it. And then at the end, all the three rules of echelon form should be followed. Okay. Similarly, column echelon form. See, there it was row, here it is column. The only difference is you have to apply it on column. All non-zero columns are to the left of 0 columns. Okay, and each pivot in a column is above the pivot in the column to its right. So this is a pivot element. And then entries to the right of each pivot are 0. So this is 0 here. Okay, and then this is a next pivot element in the column. This is same as row echelon form. Only thing is you are considering the column. So when you solve it, you will subtract instead of rows, you will subtract the columns. So let us take this example. 124, 248 and 369. So now, so this is the first non-zero element of the column. Okay, I am considering the column here. No? You see this, I'm seeing the column. So you will subtract like this column wise, not row wise now, because I am following column echelon form. Now, so this element I have to make it 0. Okay, right to the first pivot element, right of the first pivot. This has to be made 0. How will I make it 0? So if I take C2, column 2, see this is column 1, column 2, column 3. Now we are not dealing with rows, because we are following for column echelon form. So C2 will be equal to make C2 minus 2C1. So this resultant matrix will be 1, 2, 3, will become 0, 0 and 0. Will remain 4, 8, 9. What is the next condition? So this has to be swapped, right? So the last column should be zeros. Okay, so that is the column echelon form conditions. So now you just swap C2 and C3 interchange. So A is equal to A is equal to hello. A is equal to 1, 2, 3. Then it becomes 4, 8, 9, 0, 0, 0. Now this element to the right of the pivot element should be 0. How will you make it 0? So you take C2 is C2 minus 4C1. So that to make it 0, 4 minus 4 into 1 I have to make. So this will become 1, 2, 3, 0, then 0. This will be minus 12. Okay, 9 minus 12 minus 3. Then this is 0, 0 and 0. Now, this is a pivot element. The column right to it has 0. That's fine. Then this is a pivot element and then it is also having 0 to the right. So that's not a problem. Now, this element 1 is a pivot. This should also be 1, right? Then only it will be in complete column echelon form. So convert this to 1. How will you convert? This is the row, column operation you perform. So C2 should be C2 minus C2 by 3. Okay, minus C2 by 3. You get 1, right? So that is A is equal to 1, 2, 3. So 0 by 3 is 0, 0 by 3 is 0. This will become 1, then 0, 0, 0. This is my column echelon form because it is following all the 3 conditions. It is not further reducible. This is the final column echelon form. Okay. That is the steps they are given. We will solve one more example using row echelon form. Similarly, you can apply for column echelon form. Okay. Let us take this. So given matrix 1, 2, 0, 0, 1, 1 and 2, 5, 1. So what is this is the pivot element. Okay. This is also a pivot element, second row, and they are matching. Condition is satisfied here. But we have to check whether we can make some rows as 0. Okay. So let us try with this R3. Can we make it 0? R3 is R3 minus say 2 into R1. Because I want to make this 0 from this. So minus 2. I have to get minus 2 here, right? So minus 2 into R1. So this will resultant matrix will be 1, 2, 0, will remain same 0, 1, 1. Then this becomes 0. 5 minus 4 is 1. Then 0. 1 minus 0 is 1. So this is the resultant matrix. Now can I still further simplify? Yes. Because if this is the pivot element, the next element below it should be 0. How will you make it 0? So if I subtract these two rows, this will become 0. So I will take R3 as R3 minus R1, sorry, R2. So now it will become 1, 2, 0, 0, 1, 1, and then subtract 0 minus 0, 1 minus 1. Can I still further simplify? No. This is a pivot element, below it is 0. This is a pivot element, below that is 0. Okay. It is satisfying all the conditions of row echelon form. So this is in the row echelon form. This is how you have to. Now where this is applied. Now we'll come to the concept of row space, column space, and null space. So what is this? For any given matrix A that belongs to real numbers domain, that is M cross N matrix. Row space means I already told you, we represent as row of A is the subspace of real numbers n rows, spanned by rows of A. And then similarly subspace of the columns spanned by columns of A. And what is null space? Once I take example, you'll understand. I will explain it. Why these are used? These spaces reveal the structure of solutions of linear systems. When we learn the linear systems, we'll again come to this concept. Now, so let us find the row space, column space, and null space for a given matrix. How to form? So for that, there are two ways. One is you apply row echelon form and then find the row space, column space, or null space, or you apply column echelon form and then form it. Okay. So let's try an example. So given this matrix, let us find first row echelon form for this. Okay. So let me take. So 1, 3, 2, 2, 6, 4, 1, 5, 5. This is the given matrix. Now, how will I find it? So this is my pivot element 1. So I have to convert the element below it to 0. So subtract it. So what I will do, first operation, R2 minus 2R1. So this will become 1, 3, 2, 0, 0, 0, 0, 2, 3. Okay. Now, the element below this is 0, that's fine, but this element should be 0, 1. Okay, and then this row has to come to the last row. So swap them. So just swap R2 and R3. But I will get 1, 3, 2, 0, 2, 3, 0, 0, 0. Now this has to be made 1. How will you make it 1? So to make it 1, observe here, there is 3 here. There is 3 here. So if I subtract 2 minus 3, I will get it as minus 1, and then again I can change the sign, right? So R2 is equal to R2 minus R1. If I do, what is the problem here? This becomes minus 1 again. So for that, what I have to do? How will I get this 2? So that is what we have to check. So to make it, I have to multiply it by what? See, if I take, we hope you understood, if I do this, what will happen? It will get minus 1 here, because 0 minus 1 is minus 1. But it has to be 0 here. So I have to convert this 2 to 1 here. So how will I get it? So here is 3. From 3, how can I get 1? What should I multiply or divide or subtract, I will get 1 here. So such that this will remain 0. So only thing option is here, something I have to divide. How will I divide this? So if I have to get 1, so if I multiply it by, say, divide by 2. Let us say divide by 2. Okay, what I will do is R2 will divide it by 2. So what I will get? 1, 3, 2 will remain same, and then 0. So I will divide by 2, so it will become 1, and then 3 by 2 is 1.5. Now, is it in row echelon form? Yes, 1 below that is 0, here below the pivot element is 0, and this is right to the pivot element, has a right to the another pivot element. This is in row echelon form. Okay, now we will see what is this row space. How will you find the row space? The non-zero rows of row echelon form, it forms the basis of the row space. That is, you write it as row of A is equal to span of all the non-zero rows in your row echelon form gives you the row space is the meaning. So I have 1, 3, 2. If you see here, this is the final REF, right? This is the final REF. These two rows are non-zero rows. These form my row space. Okay. Now, how to find the column space? The pivot columns of the original matrix form a basis. That means, what are the final two pivot elements? These are the pivot elements, right? What are these columns? Column 1 and column 2. Not these two columns are my column space. Be careful. See, the original matrix columns C1, C2 are my column space. So this 1, 2, 1 and 3, 6, 5. These two forms my column space. How did you get that? You have the pivot element here. The columns containing the pivot elements in the final row echelon form will give me the column space. So column space of A is equal to the span column vector. This is column vector 1, 2, n. The previous was row vector. That's why I introduced the concept of vectors. So this is 3, 6, 5 forms the column space. Okay. Next, what is this null space? The null space is whatever matrix you get. Okay, the matrix is in row echelon form into x equal to 0. So this will help us to solve the system of linear equation. Now, what is this AX means what? A given matrix, you take three variables because it's a 3 cross 3 matrix, x1, x2 and x3, and equate it to 0. So what was my row echelon form matrix? It was 1, 3, 2, 0, 1, 1.5, 0, 0, 0. Okay, now observe here. So this is x1 plus 3x2 plus x2 x3. Okay, this x1 x2 x3, that is the meaning coefficients of these variables x. Then x2 plus 1.5 x3 equal to 0. So these two are the linear equations you got. Now, what about this third row? For these two rows, what about the third row? That is the concept of so much you learned now. That is why you are doing this row echelon form and column space and null space. So this is giving me the free variable. The concept of free variable, because this row is 0. So I will put, say, this x3 is equal to t is free. So using this only I can reduce or deduce the solution for these equations. That is how you solve the system of linear equations. Again, when I explain system of linear equation, we'll come to this again. Then you'll understand exactly what is happening. So now you find now x3 equal to t. You put x3 equal to t. Then you find the solutions for this in terms of t. Okay. So x3 equal to t, then x2 is equal to 1 minus 1.5 t, because x2 plus 1.5 x3 equal to 0. That means x2 will be minus 1.5 t, because x3 is t. Similarly, x1 I will get it as 2.5 t. Now this forms my null space. write it as null of A is equal to span of so T into 2.5 minus 1.5 1. That's what you have called. So we'll write it as 2.5 minus 1.5 and 1. The solutions what you got, right? These values. This is the null space. Okay. So you understood what is row echelon form. Then you understood how to get the row echelon forms, the three conditions, and then you understood the concept of row space and how to find it, column space and how to find it, and null space and how to find it. Where we will be using this is in system of linear equations. So I given all the technical meaning of and technical definition terminologies for what you are solving. So you solve many problems, but you just write this is 2.5 minus 1.5 and 1. This is how I have to solve. But procedure you know, but only thing is what is that you are solving. That is what I have explained in depth. So let us take one more example. So given A equal to this matrix, to find row space, column space and null space. So first you have to convert it into a row echelon form. I'll convert it into row echelon form. See, you can also use column echelon form. I will tell you what is the problem if you use that later. Now, find the low echelon form. So we'll write it as R3 because I want to make this 0 or this. So R3 is R3 minus 2 R1. Now this will be 1 2 0. Okay. Whatever I am solving like this, you may solve on your own way. That's what I'm saying. So need not be like this. If you want, you just follow these three rules should be satisfied for row echelon form. So you do it on your own way. Then so this will become 0 and 1. It will remain same. This is 0 1 1. So now to subtract this, R3 is R3 minus R1 R2. This will become 1 2 0 0 1 1 0 0 0. This is 0. This is 0 here. So it will not be further reduced. All three conditions of REF are satisfied. So this is in row echelon form. What is my row space? Row of A is equal to all the independent rows. So 1 2 0 and then you have span of. Span means these are the vectors, row vectors. Then 0 1 1. Similarly, column space of A is equal to these two are my pivot element at the end in the row echelon form. So column C1, column C2 is this column and this column forms my basis of column space A. So this is column 1 0 2 and then have 2 1 5. What is null space? Null space, you have this third variable is set free. That is, let us say x3 is the free variable t. Let's put it as t or some value, scalar constant. Now x3 equal to t. Then I have equations from the REF echelon form. X1 plus 2x2 is equal to 0. Then I have x2 plus x3 is equal to 0. That implies x2 is equal to minus x3, that is minus t. This 2 you have found out, x3 is given. And then x1 is equal to minus 2x2, that is x1 equal to minus of minus is 2t. Okay. Now, how will you write null space? Null space of A is equal to span of, what are those values? 1 x2 is 3, column vector. Get x1 is 2, x2 is minus 1, and then this is 0, sorry, 1 t. So that is the answer. Okay. Now we are solved using row echelon form. We'll tell the difference between row echelon form and column echelon form to find out your row space, column space, and null space. Okay, row echelon form. How will you find? First, once you find the row echelon form, all the independent rows give me row of A, row space of A. And then how will you find the column space? Column space of A. You check the columns in the original matrix. Okay, original matrix you have to check. Original matrix or the original matrix columns which contains pivot elements. Pivot elements in REF. When you convert it to REF forms, the pivot elements are there, right? Those pivot elements, columns in the original matrix form my column space A. Then you find out what is null space. You know how to find it. This is using row echelon form. If you use column echelon form, then you will directly get column space of A. Okay. And then to get row space of A, again I have to apply REF and get row space of A. And then again I have to use it to get null space of A. So what I suggest is, any problem is given, you will go for REF directly. CF will be confusing. Okay. Thank you for watching. Please like, subscribe and share. We'll continue in the next video.